Good morning and welcome to this year's Pollution Forum at WWEM. My name is Oliver Grievson and I'm going to be your host for the day. I think it's fair to say that pollution has been very much on the agenda at the minute. A lot of you I know will have watched the Environment Audit Committee yesterday afternoon or perhaps last night on re-record like me. And I think to say pollution is a very live issue is an understatement. It's a very serious problem. The quality of the rivers are of massive importance. And we saw that yesterday, the CEOs of 5 of the water companies absolutely saying, let's sort this out. Let's do things. Let's get it sorted. And so there's that appetite to sort things out, to work together, to collaborate, to sort this problem. Today, we're very much going to be talking about measurement. The whole theme of the YPAT forums this year, the 2 forums and 2 roundtables, have been why do we measure? We've all heard the old adage of measure to manage, and it still works nowadays. It worked when it first came out. I don't know how many years ago. It still works now, but we've got to temper that with what can we actually do? Why are we measuring? And it's an important question that we're going to speak about in the first session. Why do we measure? What's the point in measuring? Well, yes, it's to manage. Yes, it's to find out the situation that's going on. The water industry has always been accused of being data-rich, information poor. By adding more measurement, are we going to solve that? Perhaps. How do we get the most bang for the buck, for the environmental buck? And that's a question I really want to take today. And how do we use measurement? How do we use the management through measurement? And how do we use digital transformation in some ways to really solve the pollution problem? So I'm going to stop waffling on and I'm going to introduce our first speaker, who's Dominic Shepherd from the Environment Agency. He's the water quality manager there, and I've known Dom through the flow work he's been doing with Pete Baker and the water companies, and great stuff. But I'll let Dom talk about the need to monitor. Dom, take it away.
Brilliant. Thank you, Oliver, and thank you everybody for inviting me along to talk today. A little bit about myself. I've been with the Environment Agency and prior to that, the National Rivers Authority for nearly 30 years now. Before that, started for a short spell just after I left uni with Northumbrian in asset. I think we were doing some asset surveys for AMP1. It was my first ever job in the business. Mostly it's been around environmental planning and regulation, but increasingly monitoring, in particular around pollution regulation, has become part of my role. As Oliver has mentioned, the wastewater flow-to-full treatment monitoring program that we're doing, I lead that for the Environment Agency and have worked closely with the companies and with Oliver on that. But also I'm involved with leading our response to EDM, event duration monitoring, storm overflows, on the compliance side of things. So Keith Davis, who some of you may know, leads on the planning and development and investment side of things based on EDM, but I lead on the compliance side of things. I think the amount of monitoring we do is greater than ever before, but the need to monitor even more is greater than ever before. And that's what I'm going to talk to you about today. So next slide, please. So why monitor in the first place? Well, things are changing. Population and economic growth is increasing the demand for natural resources, for food, for housing. We're creating more infrastructure, and in turn, that's putting much more pressure on the environment. As we are all well aware, the climate is changing. The Environment Agency's third adaptation report under the Climate Change Act was published this week, and it includes quite a lot about predictions for high and low flows. This will seriously affect how we plan for the environment, for pollution management, and for regulation. We'll be looking at tightening standards just to protect the gains we've made. Environmental performance is pretty static, if I'm honest, and in some cases is deteriorating. Pollution incidents across all sectors are on the rise, slightly static in some, but for the water industry, particularly on Cat 3s, we are seeing an increased number of incidents. We're already doing more monitoring, and actually that in itself is telling us more about compliance and non-compliance. For example, the EDM monitoring, the event duration monitoring, we know that there's an awful lot of storm overflows that are discharging in dry weather. We didn't know this last year. You'll have seen in the media recently about pollution. Panorama, Country File features it. There's an ITV program being filmed tonight about pollution. And we're being quizzed at the EACs, which Oliver's already mentioned. Our chief exec, James Bevan's been there. The company chief execs were there yesterday. A massive amount of time is taken up by our technical staff and your technical staff in the companies and in the supply chain and consultancies in helping managing the reputation risk. And this actually is affecting us. It's preventing us in some cases from doing our job, which is about protecting and improving the environment. So much time has been taken up by managing the reputation risk. Monitoring is key to these pressures, and it's there to help inform cost-effective solutions, sustainable solutions, track performance, and provide the public the assurance that we need and the assurance that we are doing our jobs properly. The need to monitor is greater than ever. Next slide, please. So, traditional monitoring. Where have we come from? This is what we've done largely in the past, but not in the. This is what we were doing when I first started in the business, and up until about 10 years ago. EA took the compliance samples as well as did all the environmental monitoring, the surveillance one, the GQA as it was then, the RE reporting, and then latterly the WFD reporting. Mostly it was about, for compliance side of things, it was chemical sampling for board, ammonia, suspended solids, the sanitary parameters, but also for metals was a common thing we looked for. Environmental monitoring was a bit more involved. We've done biological sampling, and we've also done chemical sampling and sampling for macrophytes for some time now as part of our classification of water bodies. Occasionally we've done some composite sampling, urban wastewater treatment. Probably the first time we got the water companies to self-monitor. But, traditionally we didn't do much in the way of self-monitoring or continuous monitoring at all. And I suppose the question was, well, is 12 spot samples at a wastewater treatment works each year really enough to tell us what's going on? So, if I move on to the next slide, please. So, if we're looking at slide 4, which is our current approach, we've moved a long way over the last 10 years. We've shifted to OSM. We do UV disinfection monitoring, self-monitoring. We monitor dry weather flow, and that's reported. And we've recently put EDM monitoring in at the sewage works, or required EDM to be put in at the sewage works. We're moving forward with the programme of FFT monitoring at around 3,500 sewage works, which Pete Baker talked about yesterday, and I'll touch upon later. But actually in the environment, there's been no real change. Environmental service surveillance monitoring is still largely done by us as the regulator and in the traditional way. Interestingly, the public and EGN, environmental NGO pressure is for EA to do all of the monitoring because there's mistrust about self-monitoring and reporting, and this featured heavily in the quizzing at the EACs, particularly from the ENGOs. That's not our belief. I strongly believe in a combination of OSM, us doing some checks and audits, and then the development of new monitoring, new innovative techniques such as the EDM and the flow monitoring. And indeed, we'll look to the future later in the presentation. But this gives us a much better, much more comprehensive picture, but we need to work on the reputation and the understanding to help the public and the pressure groups and the ENGOs understand this. So next slide, please. So a bit of an example. This is the EDM monitoring that's gone in. We are hoping to have, or will have, full coverage of EDM at storm overflows, which monitors the length of time a storm overflow is discharging and when it discharges, and that's reported annually. We'll have full coverage by 15,000 overflows by 2023. We've currently got about 12,000 overflows monitored. That's 80%. And that's already driving a lot of investigations. We've got 700 investigations going on into frequently spillers. We are currently doing a lot of compliance investigation around the returns. It's also informing the DEFRA-led Storm Overflow Task Force. So this is where we're using the data to inform planning and legislation such as the Drainage and Wastewater Management Plans and the Environment Bill. It's underpinned a lot of the thinking around wastewater planning in the Environment Bill. Next slide, please. I hope people can see this. This is just a summary of 2020 EDM data. I'm not going to go into any detail, but there's lots of things you might expect. We get more spills in the northwest. No surprise there, it rains a lot. But it does show some oddities. And to the layman, this might seem very odd. For example, if you look at the Thames spill numbers, the average spill number and the spill duration of Thames overflows is greater than pretty much anywhere bar the northwest. The devil is in the detail, though, and this is the part of the helping people understand is how many overflows have Thames got, where are they in the network. You know, I don't think it's any reason to be alarmed. It's just they have less overflows further down the networks, which is leading to these figures. This information is great for planning and useful for compliance, but what it has driven is a massive increase in public and political awareness, and that's leading for calls to minimise or even eliminate storm overflows. So it's having a massive impact. It requires an awful lot of work for us to help manage this understanding, but it's also illustrated where we need to do a lot more work to reduce discharges in the future. So next slide, please. Another example, this is flow pass forward. Pete Baker talked about this yesterday, so I'm not going to go to a great deal of detail here. But this is the programme that I'm leading for the EA. About 5 years ago, we asked the question, what do we really know about FFT? It's a permit condition, but do we really regulate it? And it was triggered by some strange things we were finding, such as depressed ecology downstream of wastewater treatment works, which we thought really shouldn't be there. There was no reason for that. There was no other pollution source. The fine effluent was fine, and so on. I mean, that triggered some local investigations, some of which have just concluded recently, and indeed triggered some significant enforcement action. But it also led us to think about, well, what do we need to do to get a better handle on this? So, working with the industry over the last 5 years through the FFT Flow Task and Finish Group, we have got around an £80 million worth of investment, so that we're going to get 3.5 new FFT monitors and spills into storm tanks, EDM spills into storm tanks, put in by the end of this AMP, with a little bit of carryover into the next. This will give us a much better picture of FFT compliance. It will give us a picture instantaneously if we need it, what's going on, but it also allows us to do annual compliance tests. This information, we expect, when it comes through, will drive a lot of investment in FFT over the next 5, 10, even longer years, as we understand FFT compliance much more. It also will give us the public confidence, so it's that we are monitoring FFT. Currently, we're coming under a lot of criticism about this. So next slide, please. So the benefits of improved monitoring. Well, what's not to like, really? Improved compliance. We measure it so we can manage it. It highlights where we need to do more, hopefully in advance. And it also means that we can hopefully avoid pollution and minimize risk of it occurring in the first place. It also then minimizes the risk of enforcement action, so it's worth the investment. If we can monitor and predict what's happening, then we can minimize the risk of non-compliance and enforcement. Rolling better planning and optimization and efficiency in together. Monitoring maximizes the opportunity to target investment, optimize performance where it's needed, and to avoid abortive spend where it's not. In future, I hope that it can start to drive more innovation and sustainable solutions, especially to meet the climate challenge. Lastly, increasing transparency gives the public confidence, and we use it already, and I think we'll be using it a lot more in the future. But one of the great examples is we use EDM information together with rainfall radar and other information in our pollution risk forecasting, which gives us information which allows us to warn bathers when there might be poor water quality. And this has been a really successful of using monitoring in real time as part of a wider package to the benefit of the wider public. Next slide, please. So, we as a sector and as the regulator are losing what the new EA Director of Water, John Leyland, is calling the media air war. It's EDM monitoring, WFD classification, and soon FFT monitoring, which is driving the unprecedented ENGO media interest and political interest. There's far greater expectations, such as the demand for rivers to be of bathing water quality, as we've seen in Ilkley and Yorkshire, and there's a number of different schemes going on there. There's some very sophisticated pressure groups, such as WASP in the southeast, but they're now acting around the country. That's the Windrush Against Sewage Pollution, are using the data that we are collecting and providing to them to influence policy and legislation and highlight their agendas. It's taking up an awful lot of time to manage this. And as I said before, it can detract from actually trying to fix the problem in the first place. But it is capturing the political imagination, and it's really this which has driven the EAC. Monitoring not only highlights the problems, but it can provide the solution. So it can show progress, it can show things are moving forward and getting better, and this is what we need to do in terms of this media air war. We need the pressure groups, we need the ENGOs, but we also need to help them understand the complexities of monitoring and the data and how it should be used to help us in the long run. Next slide, please. This is the long run. The Environment Bill, looking to the future, includes big sections on monitoring for pollution. It reflects the political and public demand for more data and on discharges and their impacts. There is a switch from the tradition of EA doing all the monitoring in the water environment. in terms of surveillance and such like. We'll still do surveillance monitoring. We'll still have the primary role there for WFD reporting and so on. But increasingly, there will be a greater emphasis on water companies using continuous monitors, upstream and downstream of discharges. That's CSOs or storm overflows and continuous discharges to assess the impact of those individual discharges, and then scaling that up to see what the collective and the cumulative impact is. There's also a requirement in the bill for companies to publish what they're calling near real-time information on storm overflow discharges. So this is pretty much what we're doing already for pollution risk forecasting and such like in the SwimFo apps. But within about an hour of receiving the data, the expectation is that we will be publishing this on the website. Whether that stretches into the upstream and downstream monitoring data, whether we need to live stream that and things like that, then that's a big challenge for all of us. Logistically and practically, it's going to give us a real challenge, but if we get it right, it can provide some incredibly useful information and help us reduce pollution in the long run. Next slide, please. So, to summarise, the need to monitor is there. It's required by legislation, it's demanded by the public, and most importantly, it's absolutely essential if we're going to meet the challenges and maximise the benefits for the environment. Next slide, please. And that's the end of my presentation. Thank you for listening, and I'll open it up for questions at the appropriate time.
Thank you very much, Dom. Very, very interesting stuff there. And even from an instrument, I must admit, I've been ambiguous on how much we need to monitor, because some aspects of it, to be honest, worry me. But I think we'll come on to that. I think we'll bring Lee on and we'll bring Ian on and have a bit of a round table discussion at the end, because I think all three presentations this morning kind of talk at the same subject from different areas. So, Lee, do you want to take over?
Yeah, thank you very much, Oliver, and thank you very much, Dominic, as well, for a great talk. First thing. So very, very quickly, I'm Lee Upton. I am currently a environmental advisor for South West Water. I've been in the water industry since '98. Joined Severn Trent Water. I was a biologist and did a lot of process support work there. I then went to the Environment Agency, was an environment officer and environmental crime officer. Went to Severn Trent Services, which is looking at the MOD contract, which is a slightly different client base with very, very old infrastructure, which is some of what I'm going to talk about in this. And then I have moved to the Southwest, the beautiful Southwest, and working down there on minimising pollution. So very quickly, that's me. So we can move on to the first slide, please. Okay, so what I'm going to talk about is sort of how the water industry, in very, very broad terms, looks at the monitoring that we do. So I've got a bit of a risk matrix down there, not the standard risk matrix, but it's against the amount of monitoring that we do and the types of monitoring against the risk that we cover. So that could be risk to the environment, partly based on what the Environment Agency think that risk is. So the types of permits, things like that. The risk to the company of actually staying within that permit or inside that permit, the company reputation, things like that. So that's the risk building. There's also the cost element, cost of putting in new equipment, maintaining the equipment, the manpower needed to run those sites, the training requirements. There's a lot of things that goes in there. And also there's a reputational bit there about gathering more investment for companies, if we're not doing as well, we might not be seen as well. The last bit there with location sort of sits between the two. So location could be manpower, long distance, long travel times, things like that. Access issues, if it's difficult to access a particular asset, but also where it's located. Is it upstream of a triple SI? Is it on a bathing water? Is it on shellfish waters? All of those things add into that risk matrix. So that was just an overview of where we are, and we're going to look at sort of the basic, the monitoring, and then monitoring control and how we put that in. So that's the green bits. The amber is where we will use them at the right time. And the one little red one up there is that we're probably not going to use that apart from some very, very specific circumstances. So we can move on to the next slide, please. So this is what we're deeming our small sites. So we're looking more at our descriptive permits at the moment. Generally only domestic sewage, no industrial, shouldn't have any real industrial stuff in there. So a small population equivalent, package plants, small filter works, but not terribly complex, and generally old, tried, tested kind of equipment. So we do basic monitoring. It is on-site tests, turbidity tubes, ammonia test kits, and one that is overlooked, I think, quite a bit, which is observation by operators. When they go on site, they'll notice smells, sounds, changes from the norm is the best way to put it. Has the colour of that effluent changed slightly? Has the smells changed on site? And all of that, which is generally difficult to quantify into electronic information, but it will be recorded. There might be other bits and pieces depending on where it is. So they might need pH or DO control monitoring on site, and that would be generally handheld. There will then be only critical asset monitoring. So if we're looking at RBCs or filters, we're really looking at loss of rotation sensors, that kind of thing. Anything that if it breaks down, the process stops. And that will generally be it for these kind of works. Obviously, if it's aeration, we're looking at blowers, and we probably have, if it's a powered site, a loss of power kind of monitoring alarm that says we've got a problem here. The recording and monitoring of the data is very, very basic. You've only got those signals coming off. Any other information is what is recorded by an operator, probably in text. So it's not terribly easy to get that information out and use it in a really useful kind of format. And that data is rather limited. So your small sites, your descriptive sites, are not going to be visited that often. It might be weekly or even up to monthly on some of these sites. So we're not going to have a lot of data on there, but it doesn't mean that they're not doing the job. That's the risk. So if we can move on, please. So from the top end of our small sites to our medium sites, we're now looking into our numeric consents. These will often have storm and emergency discharges towards the top end. They're generally more complicated. So at the bottom end, it might be multiple package plants put together. So we've got flow splits and things like that to deal with. But it could be larger filter works, oxidation processes, things like that. So a lot more complicated. Generally, these will have other complicated processes compared to our simple sites. So they're going to have mechanical screening and things like that on site. So there's a lot more to do when we're looking on site, we're going to do that basic monitoring because it's a good method of seeing where different parts of the process are doing, and we can do that through process. So if we think we've got issues, we can work back through the process doing all of those kind of things. We're monitoring those critical parts of the system as well, just like on the basic ones, but now we're moving up a bit. We're doing a lot more monitoring. So a lot of these will fall under the MCERT's flow monitoring. So now we've got some real data, some real-time data on the back end that we can interrogate. We've probably got level monitoring on storm tanks, things like that, so we can see when they are filling, when they're not. As we've already spoken about, we've got event duration monitoring. Certainly on the larger sites, they will fall under that. And we're starting to get some kinds of automation. So we might have desludging on PSTs and humus tanks, but only on a timer. Nothing exciting, but only on timer. And then we're into our OSM, as Dominic's already sort of covered, and our urban wastewater treatment sampling as well, which is all done by a third party from us, even though, as Dominic said, it's the water industry, but it has to be done by a third party so that it's fair, so that we can't alter when it's sampled and things like that. So we do get a degree of scrutiny from that. The recording and monitoring of data, we've now got quite a bit more data. We've got real-time data almost on a lot of these things so that we can interrogate them as it happens. This data is held electronically so that we can easily access it wherever we are. And during the pandemic, that has been a godsend for all of us working in process controls. It's easier to gather, it's easier to report, and we can report it fairly good. What I will say about this whole bit is it's very resource intensive. So this is where most of our manpower spend their time. This is going to be at the bottom end, definitely once a week, site visits through to 3 times or more, possibly weekends, depending on the risk that is put against it that we see from that. So that gives you an idea of we're getting a lot more complex now with those works. So next slide, please. So now we're on to our high risk, our larger sites. So these are the biggies from around the country. These deal with cities and things like that. So numeric consents, again, storm and emergency overflows, probably both on these, maybe multiple storms. So we've probably got settler storm and growth storm on this. These are a lot more. Complicated sites. They treat very large volumes of sewage. They've almost certainly got some kind of industrial effluent in them. So they're having to deal with probably slightly different processes. And in that, to manage these really large sites, we have to put in more automation, which is more cost. So we will use the basic observations and basic checks that we've done on all the others to check that our automated equipment is actually doing what it should be doing as a secondary check. So we're still doing that, and they're still relying on observation, but we're doing that to make sure that the data that we're getting off from our overriding information that we're getting is correct. So monitoring, yeah, we'll have flow monitoring, we'll have both probably now moving into this AMP period, inlet and outlet. We'll be level monitoring at probably several places throughout the sites, because we'll have intermediate pump stations and things like that as we move through. So there's a lot more data of where these flows are going and at what times, and that gives us information on where we might have individual asset problems in between. We'll have a lot of equipment failure monitoring because there's a lot more automation, so there's a lot more things to go wrong, so we need to react to those as quickly as possible. We've got the event duration monitoring, but we've probably also got on these now, we're looking at action limit alarms. So responding, because we've got this real-time monitoring, we can respond before we get to a problem. So we will know the time to consequence. So we can go, right, we need to act at this point here to stop an issue later on, should we have some kind of failure on site. And we will have the OSM sampling, which is a lot more increased on these larger sites. There's a lot more demand for that information, and the urban wastewater as well. But now we're moving into, as we've sort of alluded to, monitoring and control. So we will be controlling through the process. So we might limit flows and control them through a process to make sure that we get the best out of that process. We might be diverting flows through to and holding them in balance tanks or holding them in the network to manage that flow through our system. One of the things that we've also got is that we can inhibit certain processes and divert into others to make sure that we get everything that the best effluent that we can in the situation. So it could be high level flows or things like that. So, we have also measuring difference between different meters. So that could be level meters, that could be pressure monitors. We can monitor the difference between these two, which gives us another reading. So we've got another view of what's actually happening, not just that it's climbing, but that we've got a differential, and that then can feed into an action limit, which then gives us something to react to stop this. For these larger sites with SCADA, and because we've got a lot more automation, we can remotely control these sites. That's one of the great things about SCADA. We can, if we need to, reset the site from a central location. So we don't have to send somebody out at 3 o'clock in the morning. It might take him an hour to get there, an hour, he might be on another site dealing with another issue, and it might be half an hour before he can get off that site, then an hour to get there. So if we can put some of or use some of this remote control that's in there as it gets more complicated, then we can save ourselves some time. All of this automation and control allows us to treat these huge volumes in some respects with less manpower, but it's at a cost. It's at a financial cost of putting all this equipment in and maintaining it. But what it does do is it gives us lots of real-time data that we can use to stop issues on site. And that's where we are with that. So if we can move on, please. So in AMP 7, as we've already touched on, we've got the flow to full treatment and EDM under UMON 3 and UMON 4. This gives us a great opportunity to use this information that we're putting in to link to other data sources using sort of multiple input alarms. So if we've got high levels coming in, but we're not seeing them going out, if we've got high levels coming in, but with it's not going through the right part of the process and things like that, there's a multitude there of things that we can link together to give us a real picture of what's going on. I'm going to come back to UMON the AMP7 thing at the end with the demand for data, because there is a question over data. But new technology, so mobile communications means that we can have monitoring on sites that we didn't think was possible. I'm sort of thinking about my MOD days now, where we've got sites right in the middle of moors, 30 miles away from anything. We can now monitor that easily, cheaply, so we can get that. As technology moves on, the cost greatly reduces. The size of bits of kit, so we can put them in better places. We can swap bits of kit out for newer, more information, live information, rather than, yes, we've got a bit of kit, it goes in, but we have to go and download the data every month or whatever. We can now get that live, so that comes in. And greater functionality, we don't have to go to site. A lot of the new technology is smart technology. We don't have to go and dismantle it or plug in. We can Bluetooth to it. We can alter settings if they're wrong. We can diagnose what's wrong with stuff by Bluetooth, which is amazing, So we can get a lot more functionality, a lot more bang for the buck, as Oliver said earlier, out of this stuff, but at a cost of replacement. So the challenges that we're seeing is that we've got an aging infrastructure out there. There's a lot of old kit. That gives us compatibility issues. We can't just go and pick up a new thing off the shelf because it doesn't talk in the right language. It doesn't fit with the controller. Things have moved on, digital, analog, and all that kind of stuff. So we've got compatibility issues, which might mean as things become obsolete and break, we have to spend larger amounts of money than we would have done in the past, where we could just take out a monitor and put another monitor in. With that old kit becomes reliability. If we're struggling to pay for upgrades, and we've got a number of upgrades to do, and we're struggling to upgrade the whole lot of the infrastructure, then we can get reliability issues with that old kit and finding the spares and that's the last bit, which is cost of replacement. So cost of finding spares for existing old infrastructure kit is difficult, but also then you might have to do a larger upgrade, which is a bigger cost, and that has to be weighed against the challenges that we've got. Demand for data, as Dominic said earlier, there's a thirst for data out there, both regulatory and the public. So live data request is coming, and just wanted to sort of touch on that, which is the data for UMON 4 means that they're looking at a site being recorded every 2 minutes, which will give, for the 3,500 MCERT sites out there, about 525,600 pieces of data per year, which is massive. So we have to then pay for the upkeep of that, and that's every year. So we've got data storage issues, we've got data management issues. If you add the 42,000 monitoring sites for CSOs, we're at 1.471 billion pieces of data for all of that. So that is a massive challenge for managing that amount of data, for data quality checking, for just the storage side of this. So that is really, really massive. And the more data that we produce, the more third parties are going to want to request that data, which means that we have to go through that process a lot more. Every time data is requested, we're going to have to pull it out. We're going to have to data check it, and then we're going to have to package it up and send that out. So that's a massive challenge, I think, for the company side of things. So moving on.
That to me that was absolutely fascinating. I love the bit of Ofwat's point of view of the problem. I think that was a really fantastic summary. And I also, the last bit on, are we really going to go into that massive investment program? I think it comes to it. I think yesterday in the Environment Audit Committee, I think one of the CEOs came up with a cost of about 200 billion to separate the sewers. To me, my rough mathematics on the number of households, that would be about £1,200 per household per year for the next 10 years. So I think that would put the average water bill up to about £1,500 a year, which I think there'd be riots in the streets. And so, yeah, no, a massive infrastructure project isn't feasible, to my mind. I'm very happy to be wrong and that to be done, but also the practical elements are there enough civil engineers in this country to deliver that? And I think you'd probably go no. I've certainly seen from the Environment Audit Committee, looking at it yesterday, monitoring as well. We had from Dom the upstream, and Lee also said the upstream and downstream, how many overflows, how many treatment works. I make it somewhere, I've had various figures for various things, but I make 10,000 treatment works, 3,500 under inserts, which is what Lee was saying as the medium sites and above. I think Dom said 15,000 overflows. 2017, I had a figure of, I think from Phil Hume, about 17, 18,000. You were talking about 50,000 measurement points, more or less. And the cost of that absolutely staggers me as well. But maybe that's the way we need to go. We have had some questions from the panel. This one's to you, Dom. How explicit is the requirement to continually measure water quality in a river? Getting traction to supply water quality kit to water companies is still difficult.
Yeah, it's included in the bill at the moment. It was a Lord's amendment to put in upstream and downstream of all storm overflows and continuous discharges. There is something in there around it needs to be. The regulator has a say in this, and I think what we need to do is, I think the requirement will be there. It will be to go away. The public demand is for it. I think as it evolves, the practical implication of that will be the challenge, and that will be we've advocated that it needs to be done on a risk basis. And that there will be certain circumstances where it may not be possible. But I think the principle is there, but there is a caveat in the bill as written at the moment that allows for some risk-based decisions to be made around that. But it will, certainly if that part of the bill gets passed, then we will be doing it. It will be a question of or outfalls, and then how long is that going to take? Because, as you say, Manson, the practicalities of it, as well as having enough engineers and so on. I'm just thinking about, well, it's not as easy as just upstream and downstream of an outfall, because these are supposedly permanent structures. So you're looking at gauging station type infrastructure. With vandal-proof, flood-proof, and all of these things. So all of these things need to be considered. the public desire is there. Certainly the political desire. What they're seeing is it's because of the EDM data really that we're now seeing. People are becoming aware that storm sewage goes into rivers. There wasn't a great awareness apart from in very small sort of communities of NGOs and so on and so forth. What it has, it's got it on the political agenda, and I think what we need to do is understand that this is coming. We will have to do it, but again, what's the pace? How we're going to do it? How do we make it risk based? And there will be lots and lots of discussions with Ofwat and with DEFRA and the NGOs, be largely through the Storm Overflow Task Force, about how we implement that when it comes in. At this moment in time, we don't know exactly what's coming in because it's just a bill and it's got to be passed, and there's lots of discussion to be as yet. But I can't see it not going in some form. So we have to, as a sector, be able to respond to that.
You see, myself as an environmentalist, an engineer and a scientist, I have got this duality in me. And I realise environmentally it's absolutely the right thing to do. As somebody who's got a huge amount of experience in instrument installations, 100% agree with you. It's going to be gauging structure like installations, and it's going to be incredibly costly. And then on top of that, the operation and maintenance. I did a rough calculation in my head this morning. Even if you use an ISE technology, relatively inexpensive compared to gauging structure and up and downstream, you're looking at least £1 billion. But then on top of that, you're probably looking at about 1,000 instrument technicians nationally a year at a cost of say 100 million, and then the renewal capex cost on top of that. So yeah, I mean, the environmentalist in me says absolutely the right thing to do. There's governance issues of who should be measuring in the river. Then there's maintenance, operation and maintenance issues rightly brought up on operation and maintenance, instrumentation, absolutely. And then we're also possibly looking at, dare I say it, an MCERT style scheme for that quality assurance. And I know that's jumping ahead, but we've got to have that quality assurance because, yes, you pointed out the 400,000 overflows, and I think it's something probably to discuss in the next session. But in terms of the ENGOs, I think we've probably got a duty to give them more information about what those spills are. Are there full spills due to instrument problems? Are there spills in dry weather? Are there? And then that's bringing data sources from other other areas.
That's the air war. That's the media war. It's the understanding of the need for storm overflows as it stands, or as the chief execs discussed at the task force yesterday, it is the order of £200 billion to eliminate storm overflows potentially, and part Environment Bill asks for a report on how you might eliminate storm overflows and what the costs would be and so on. I think it says within a year produce a report, and I think we've all come up with figures. I think that 200 billion is similar to figures we came up with through the storm overflow task force. I think it was more than that, but it was the order. So we've got a good idea already. We're being asked to produce a report on that, and then that will inform the political thinking there. But I think a big part of it is that understanding of the need for storms. What's the difference between a compliance spill and and a non-compliant spill, as you say, but the public don't care. They just see storm sewage, and it's always raw sewage in the media. It's never storm sewage going into the environment, and that's I think is when this information starts to come through and required by the Environment Bill and such like. Before that does, we've actually got to get that media war right, their war right with the customer base, so they truly understand. Going back to what Ian was saying, I think we're very much for sustainable solutions to these storm overflow issues. We don't want to pump and treat surface water. We want to get the surface water out the sewers, and through suds and so on. I think the critical element there is the demand. Well, we will be challenged by NGOs and pressure groups in particular, who have got the ear of politicians to get to solutions quickly, and I don't want to see the pressure for quick solutions driving the wrong solutions.
Yeah, I'd agree.
We've got to work together on that.
To me, on the monitoring thing, that's especially important because we can very easily run into the wrong solution, and that's. But equally, I think some of it is probably, if we say £200 billion to a customer, that's monopoly money and doesn't mean anything. If we say it's going to be over the next 10 years, it's going to be 1,200 quid on your water bill, that's going to mean a lot to a customer, which is really important. And I think the other challenge, I think it's probably where you can come in, Lee, and is open data, 100% right, brilliant, fantastic. But how do we present that? Because I think, Lee, you talked about 1.7 billion. Depending on what data actually goes out, that can be into tens of billions of pieces of data, which is useless. It's great for the data scientists out there who want to play with the data, fantastic. But what does the customer want to see? How can the stakeholder consume that information, or do they want the raw data? Some will want raw, some will want, Yeah,
I think there's like Dominic sort of touched on there, there's an education piece there, because you can give them all this information, but if they don't know what they're looking at, they can get it and they can make whatever conclusions they want, exactly like every storm overflow, if it's discharging, is not compliant and it's raw sewage, and oh my God, it's the worst thing in the world. But it's not always like that. It's a compliant storm overflow 6 times, dry weather flow, all that kind of stuff. So there's an education piece that goes with it, and it probably links on to the education about what people are putting into the sewer as a whole piece, probably for all three of us here groups. The water industry, the environment agency, and Ofwat, educating as a whole as to this is what it means, and that bit there comes out with then showing them the data that they need, that they want to see, but in a way that is clear and shows the correct messages.
Well, one of the things that came out of the Environment Audit Committee yesterday, and I picked up on, was a more recent figure for the cost of blockages, and I think that was 200 million, if I remember correctly. And that's, again, that could be a piece. Well, that's everyone. That's costing you £10 a year.
Yeah.
Quite simply, is that the case again? And again, Ian mentioned the education piece with his kids. One of the things we're talking about later in the round table is net zero, and we've got a great example of water stewardship from Denmark. That piece that Ian was saying, kids are being taught, that was done a generation ago in Denmark. So is it a cultural and generational thing? Possibly. I remember when I worked for Yorkshire Water, seeing little 4 or 5 year old kids being taken around Esholt, and it was the most wonderful thing to see. I think some of the water companies are doing a massively brilliant educational piece. I love the stuff that Severn Trent Water did over the pandemic of doing virtual wastewater classes. So again, there may be a generational thing. And again, we'll talk about it this afternoon with net zero, the potential of serious gaming as well. Anyway, I think we've run out of this time for this session. I'm sure the questions could go on for absolutely ages. So thank you, Dom. Thank you, Lee. Thank you, Ian, for a fantastic introduction to the Flow Forum. It's been really, really valuable. We're going to take a comfort break now for 15 minutes. Do come back at 11:15, where we've got Jacqueline Diaz-Nido from Yorkshire Water, Rob Stevens from RS Hydro, and Christine Colvin from the Rivers Trust, all talking about how we measure, how we can communicate with the customers. So thank you very much for the first session, and see you all in 15 minutes.
Thanks, everybody.
Cheers.
Thanks, everyone.